So as it is a numerical heavy chapter, the chemical kinetics, we have to solve as many numerical as possible. So that is what we are doing. So today's problem, first problem for today, let me write down. Question is, the rate of decomposition in CCl4 solution has been measured at 318 Kelvin, and the following results were obtained. The chart is given. This is time versus concentration. Concentration is given in molarity. So it is 0, 2.08. Here it is 135. Time is given in minute, by the way. It is 1.91. Then it is 339 and it is 1.67, and it is 1.35. Then it is 1680 and it is 0.57. Question is, find the order of the reaction. Question is, find the order of the reaction. And second is, what is the half-life period? What is the half-life period? So let us see how it can be solved. So we have to find the order. So let us assume that it is a first order reaction. So say the reaction is of first order. We are assuming that it is a first order reaction. Now let's see how can we solve it. So in that case, K is equal to 2.303 by T log of, it is C0 by C, that means that we can write A0 by A. Here, so there are various data, right? Let us see one by one. So this is the first data. We have to understand when T is equal to 0, when T is 0, the concentration of the reactant should be maximum, so that value of A is 2.08. That we have to understand first. So at T is equal to 135 minute, we have to write K is equal to 2.303 by T is 135 log of A0 is 2.08 divided by A. That means at this point of time, what is the value of A? 1.91. This is the first case. So when T is equal to 339 minute, then suppose we are calculating K2, 2.303, it is 339, it becomes log of 2.08, again the same, and it becomes 1.67. Next is T is equal to 689 minutes. Here it is K3. Here it is 2.303 by 689 log of 2.08 divided by 1.35. So now we have just put the values. Let us see what are the outcome of these values. Remember, you have to use the log table. I have pre-calculated. So my first value is 6.32 into 10 to the power minus 4. So the second value that I am getting is 6.30 into 10 to the power minus 4, and the third value that I am getting is 6.33 into 10 to the power minus 4. If you see all these values, these are almost same. Almost same. What does it mean? That this K remains more or less constant across all these values. That means the equation that we have chosen is a correct equation. That means it is definitely which order? We have chosen this as a first order, and it is actually a first order reaction. Now for first order reaction, we also know that K, we have to T half is equal to 0.693 by K. So you just put this value, K value is 6.30 into 10 to the power minus 4. If I put this value, I will be getting 1.097 into 10 to the power 3 min. So the process of solving this is put the value in the first order rate equation. If by chance it is not following the first order rate equation, then the K value will be different. In that case, we have to go for zero order or second order. Second order is very rare, mostly zero order and first order. And then from getting any of the K value, you put it here. You have got two choices. Either you take the average or you put any value. Either case, it will be appreciated. So this is how we solve this type of problems. This particular problem which we are going to solve now is different in a way that it is for the first time we are introducing the pressure term instead of the concentration term. So let us see how it goes. The question is, the following data were obtained during the first order thermal decomposition of N2O5. So directly I am writing, or first order thermal means with the help of heat, thermal decomposition of N2O5. What is happening there? You see, the reaction goes like this: 2 N2O5 giving rise to 2 N2O4 plus O2. So the values are like this: serial number, time, and total pressure. So time I can write here, and the total pressure. So serial number 1 and 2, time is 0 and 100, and the pressure is 0.5 and 0.512. Question is, we have to calculate the rate constant. Now pressure is calculated in atmospheric pressure, that is ATM. A different type of problem needs different approach. So here, let us first understand the concept carefully. See, according to the question, if I rewrite this equation, N2O5 giving rise to 2N2O4 plus O2. So suppose initially, as you know, at time 0 the total pressure is 0.5. So it is 0.5 atm. And obviously it is 0 and 0. Here we are talking about T is equal to 0 as well. Now when T becomes 100, then say for an example that the X amount of oxygen is formed. If this is formed in X amount, so definitely this is going to form in 2X amount. So how much will be reduced from here? It should be 0.5 minus 2X because of this coefficient term, right? This much I think everyone has understood. Now if I calculate the total pressure, it will be like PT should be this much, 0.5 minus 2x plus 2x plus x. So it becomes 0.5 plus x, like this. So we are getting 0.5 plus x as the total pressure. Now, if I want to find out the value of x, it obviously becomes Pt minus 0.5. So both of these are important. Okay now? So these are already calculated. Now the situation is when T is equal to 100 second. When T is equal to 100 second, Pt becomes how much? It is 0.5 plus, here you see, for T is equal to 100 second, the Pt should be 0.512 already given. So the value of x now is, for the value of x, it is Pt minus 0.5, which is nothing but 0.512 minus 0.5. So which we are getting as 0.012 atm, which is the value of x. So if the value of x is determined, the value of x over here is the pressure of O2. So it is nothing but partial pressure of O2. And similarly, if we want to calculate the partial pressure of N2O5, if we want to calculate, that means this much, it will be 0.5 minus 2x. You have seen this value already. So it is 0.5 minus 2 into 0.012. So how much we are getting at last? We are getting 0.476. 476 atm. So these are obtained. For a first order reaction, we know if we have to find out the rate constant, the value will be like K is equal to 2.303 by T log of, in this particular case, it should be P0 by Pt. So it should be P0 means initial pressure divided by final pressure. Initial pressure of this, which is, I can write N2O5 divided by, you can write like this also, divided by Pt of which term? The same term, that is N2O5. It is like R0 by R only. It is just a replacement of R0 by R. Similar thing. Now the values are 2.303 by t, this is a separate part meanwhile, log of this value, how much we have obtained already? This is already 0.5, and pt, that is the calculated value, should be 0.476, which we have obtained few minutes back. So now this is to be solved. So calculate this much, how much we are getting. Before getting the answer, let me tell you the process. We have tried to obtain the total pressure, because our job is to replace the concentration term by the pressure term. So we need to have the pressure of PT, and PT is basically represented by this particular term, 0.5 minus 2x, as per the coefficients. So for that we need the value of x, that we have calculated very carefully. So we are getting the value of pressure of N2O5 at time t, that means at 100 seconds. Now we have got this particular value. So when we are calculating, I'm just directly write down the answer. It is 4.93 into 10 to the power minus 4. 4.93 into 10 to the power minus 4 second inverse. You can easily calculate. Now this t, which we have not written, how much it should be? Before writing the value, if I put down the value of t, it is at which time we are talking about? 100 seconds. So here it should be 100. And we are getting the value as 4.93 into 10 to the power minus 4. Again, this value is already pre-calculated. You need to put the value of t, see on this part, with the help of log table you put the value, then only you will get the correct answer. So this is a completely different type of problem compared to the problem that we have solved. I think it is a prototype. Similarly, so many type of problems you will be observed in the various NCERT books and the questions and the previous year's problems and all. The next one is a similar type involving pressure, but a different type of calculation. Little bit different type, I won't say it is absolutely different. Question is the following. The following data were obtained. The following data were obtained during the first order thermal decomposition. During the first order thermal decomposition of SO2 Cl2 at constant volume. At constant volume. The reaction is given as SO2Cl2 giving rise to SO2 plus Cl2. SO2 plus Cl2. Needless to say that all of them are gaseous. Some experimental values are also given. Experimental values are like experiment, time and total pressure. So it is experiment, time and total pressure. The values are like this. This is the first experiment, second experiment. So it is 0.5 and 0.6. Now, the time is 0 and 100. The question is, calculate the rate of reaction when total pressure is. Calculate the rate of reaction when total pressure is 0. It is given as 0.65 ATM. Very, very interesting one. Good prototype, I would say. If we can solve this, we can solve many. So let us propagate. Since it is given as a first order reaction, that means we can apply the first order rate equation. That is, before doing that, which rate equation should be applied? SO2 plus Cl2. We were assuming we will be applying 2.303 by T log of, it is the concentration of A divide A0 by A. Now it has to be replaced definitely, but how can we replace this? See, initially when it is Pi, it is 0 and 0 at T is equal to 0. When it becomes T is equal to 100, at that point of time, Pi, SO2 Cl2 means this value, initial value, if I write this as Pi minus X, it becomes X and X. So if I want to calculate the total pressure, it should be Pi minus X plus X plus X as per the coefficient. So it is Pi plus X. Now, as per the question, this total pressure is 0.65, and it is also given that the value of Pi, how much it is? 0.5. So X, value of X is definitely 0.65 minus Pi, which is 0.65 minus 0.5, which is 0.15. Now what we have to calculate actually? The rate of a reaction. So in order to calculate the rate of a reaction, the rate should be K into concentration of reactant, which is SO2 Cl2. So first of all we have to solve this part. From here only we should be able to write it is K is equal to 2.303 at T is equal to 100. It should be log of concentration of this one, which is Pi, divided by check carefully, we have to write down the concentration of this Pi minus X, but the X value, X is from here, the value of X is Pt minus Pi. So when we are writing Pi minus X, you see, if we are putting the value of this one, it should be written as the pressure of SO2 Cl2 at T is equal to 0 and the pressure of SO2 Cl2 at any time. So from here we should be writing K is equal to 2.303 by 100 log of this value should be as it is P0 divided by Pi minus X. Now X is again what? This value. So I can directly write down Pt minus Pi. So here we can further write down 2.303 by 100 log of, it is P, instead of writing P0 I can write Pi actually. So it is Pi divided by, here you see 2Pi minus Pt. This is a very, very important formula which will be utilized. After this mathematical derivation, now we are in a position to put the values. It is K is equal to 2.303, so I am putting T on the up to now. It is 100 log of These values are, according to the question, pi value is how much? 0.5 divided by 2 into 0.5 minus pt. pt value means we have already calculated, it is 0.65. So from here we are getting 2.303 by 100 log of 0. We are ultimately getting 1.25. So the answer that we have obtained, pre-calculated answer of course, it is 2.3 into 10 to the power minus 3. That is 2.3 into 10 to the power minus 3 second inverse. Now, if we continue to calculate, we will be obtaining the rate of this associate rate of this reaction. So rate of this reaction we have already mentioned how it should be calculated. So I am calculating it above so that you can see it together. So I am calculating it in this part. I hope all of you have written down the question. So now we are calculating rate. So rate of this reaction is, according to this question, is K into SO2 Cl2. K value is obtained already. K value is how much? It is already 2.3. 2.3 into 10 to the power minus 3 into concentration of SO2Cl2, that is this value actually, pi minus x. Now pi x value we know, that is 0.15, and we have already calculated the value of pi also, that is 0.50. Here you see x value we have calculated, pi is already known, so it is nothing but pi minus x. You can write like this, k into pi minus x. So as a result, the k value is 2.3 into 10 to the power minus 3 into pi minus x. Pi minus x means the value of pi is 0.5 minus 0.15. So it is basically 0.35. Now if we calculate the two, we are going to obtain the pre-calculated value as 7.8 into 10 to the power minus 5 atm per second. So it is, we are getting 7.8 into 10 to the power minus 5 atm second inverse. ATM because the pressure will be in ATM and K value will be in second inverse. So this is the answer. So it is a long calculation. What we have done is, we have first replaced these two by the pressure value. We are getting 2 pi minus pt. This is an extremely important equation, this one. Do remember this. Remember means you have to obtain. Then we have calculated this part, that pt value is total pressure will be 0.65, which is pi plus x. From there we know the value of pi according to the given data at t is equal to 0. Then x we have calculated. So now we know total pt, pi and x. So we have just replaced this value over here, we are getting k. After getting k, we know that the rate is depending on the concentration term. So we have written down this. This value is pi minus x. We have written down those value individually value also. Now we are getting the rate. So this is how these three different type of problems should be solved.